In this video, we will go over how to determine where a function is positive or negative. A positive interval, or where the graph is positive, is all of the x values where the graph is above the x-axis. And the negative interval is the x values where the graph is below the x-axis. And so, like when we're describing increasing, decreasing, and constant, we're going to use only the x values. So you can kind of pretend like the y-axis doesn't exist. Just kind of eliminate it from your brain. All right, so in this graph, the graph has a 0. Zeros are really helpful when finding positive and negative because wherever there's a 0, right, that's where it's going to cross the x-axis, and it's crossing from being negative to positive at that spot. So that's a helpful thing to find. And so I'm looking here and I have an x-intercept at 2. And so that's going to be kind of like a critical point here. The section highlighted blue is positive because it's above. This is where the graph is above, and then this is where it's below. And so the part that's above is my blue part, and it starts at 2 and it goes above the x-axis for the rest of the function. And I use interval notation. I'm choosing to use interval notation. Some people use inequality notation, and I use open interval notation for positive, negative, because that is typically what you would see in a pre-calculus or calculus course. Because 2 is a 0, even though it is a part of the graph, we don't use a bracket because it's not physically positive or physically negative at that spot. The purple section is the negative section, and it's got an arrow pointing this way. We're using the x-axis all the way to the left, which is going to keep going left forever, is negative infinity, and then it's going to stop being negative at that 2. All right, so let's hop into some more examples. All right, number 1 here, I'm going to find my 0. All right, my 0 is at x is equal to 4. And then I'm going to highlight my positive section is above. I highly recommend highlighters for this. And my purple section is below the x-axis. And so I'm going to write those intervals down. My positive interval starts at 4, and it goes above the x-axis all the way to the right, so infinity. My negative section of the graph goes from negative infinity until 4 because it's going down, but really it's going to get wider and wider to the left and to the right on this direction. Even though it looks like it stops getting wider, it really does get wider and wider. All right, and the next one, I have 2 zeros. I have one at -1 and I have one at 3. So those are going to be some critical points. It is positive above the x-axis, which is this blue section. And that blue section goes from -1 until +3. So as you can see, my negative section is split. And this is the more complicated situation. You've got 2 sections, so you're going to have a union. So from the left-hand side, negative infinity, it's negative until it gets to -1. And then I use a union to show, hey, there's 2 negative sections, not just 1. The other negative section starts at 3 and goes below the x-axis for the rest of the graph, which is forever to the right, which is positive infinity. Remember that you can pause these at any time and try the questions before continuing to watch. Number 3, I'm going to find my zeros. They are at -2 and +2. Those are going to be my critical points here. My positive section this time is split into 2 sections, and my negative is in the middle. And so my negative section goes from those 2 values, -2 to 2. And my positive section is from the left side, negative infinity, until -2. union, because there's another section at 2 until the right forever, which is positive infinity. My zeros for number 4 are going to be 2 and 4. I have a positive section in the middle of those. It's above the x-axis there. And so when it's not split up, it's a little bit easier to do. We just say 2 to 4. The negative sections in purple are split up. The arrow is pointing to the left forever. So I know that it is negative on the left-hand side, negative infinity until the 2. Union, after the 4, it dips back down, and it's going to stay below until forever to the right. So positive infinity. All right, a linear graph. Love a linear graph. It's not as many pieces here. We've just got 1, 0. So I have x is equal to -2. And it's positive above the x-axis. It is negative below the x-axis. And it is positive from negative infinity on the left-hand side. It's pointing to the left until that value -2. And then at that value -2, it starts being negative. And it's going to do that forever to the right, which we call positive infinity. Something I want to point out to you that has helped my students is that however many zeros you have one more interval of positive or negative. So for example, in number 5, I have 1, 0, and I have 2 positive negative intervals. In number 4, I have 2, 0, I have 3 intervals. And so that might help you when you're figuring out what you should be writing down. All right, number 6, we have a unique looking rational graph. Well, this is the parent graph for rational, so it's not unique in the rational world, but it is a unique shape. So it is positive on this half of the rational graph, and its other half is below the x-axis, and so it is going to be below the x-axis. There's no zeros. So the 0 doesn't help you here. It's never going to cross the x-axis. So you can't use that trick I just told you where you find the number of zeros and then that one more than that is usually how many intervals you have. That doesn't really work here. So it's not an always trick. It's just a lot of times trick. So the purple section, my negative section, it goes from the left, negative infinity until 0, but it doesn't touch 0. And then it's positive after 0. And it's positive until infinity. It goes to the right forever. Okie dokie. You can also think about this as, right, this half of the number line is where the graph is below, so it's negative, and this half is above. So that's why it's split at 0. Split at the origin. Number 7, this entire graph is above the x-axis. And so because of this, it does not have any zeros. And so it is always positive, and it is going left and right forever. And so we say negative infinity to positive infinity. There is nothing that's going to make this graph go below. So this is not a thing. All right, we got a 0 again at -2. All right, so it is positive from that point on, and it was negative before that. It was below the x-axis before that. And this one might be where interval notation could be argued. You could think that, okay, well, it starts at -5. I'm actually going to use a bracket here. Very rare scenario that I use one, and it's because that x value, -5, is a negative value. It is below the x-axis. It stops there. And it's going to go right until -2, and it's going to be below until that 0. And I'm going to use a parenthesis there because we don't call zeros negative or positive. It's just 0. All right, the positive section goes from -2 to infinity. All right, number 9, our last one here, we've got negative 8 as a 0 and positive 8 as a 0. So I'm hoping that you've seen that these critical points are always used in the intervals. We've got a split situation again. We're positive over here, we're above the x-axis, we're above the x-axis over there, and then in the middle, this is where we're below the x-axis. And so my positives are split from negative infinity until negative 8. Union, I pick back up being positive at 8, and I keep being positive forever to the right. So pointing forever to the left, we say negative infinity. Pointing forever to the right, we say positive infinity. And then the nice interval in the middle that's negative just goes from negative 8 to 8. And this is how we find where a function is positive or negative.